A particle's position vector r is given here, seems to be measured in centimeters, and the time is in seconds. A plot of the path of the particle is shown below. Express the path of the particle as a Cartesian equation. So that means we need to eliminate t. So looking at the position vector, we have that x is 4 cos 2t, and that y is 2 cos t. Now we know that cos 2a can be written as 2 cos squared a take away 1. So therefore x is going to be 4 lots of 2 cos squared t take away 1. So that means that x is equal to 8 cos squared t take away 4. Now y squared is 4 cos squared t. So x is going to be 2y squared take away 4. Now, in this case, we should really state a domain for the function. We can see x is 4 cos 2t. Now, cos 2t has a minimum of -1 and a maximum of 1. So we can say that x needs to be between -4 and 4. Determine the speed of the particle when it first reaches the point where x is -2. Now we know that r was 4 cos 2t, I believe was the x, and the y was 2 cos t. So x equals -2 means that 4 cos 2t is equal to -2, which means cos 2t is -1/2. So let's think about where that would happen first going this way. That would happen in the s quadrant, and it would mean this angle was 2 pi by 3. So 2t is equal to 2 pi by 3, giving us that t is pi by 3. So the velocity vector is, well, cos differentiates to negative sine, and don't forget to use the chain rule on this one, so it's going to end up being -8 sine 2t, and this one's going to end up being -2 sine t. And we want v of pi by 3. So that's going to be -8 sine 2 pi by 3 and -2 sine pi by 3. And so the speed would be the square root of 8 sine 2 pi by 3 squared plus 2 sine pi by 3 squared. So I'm just going to convert these into degrees. Let's just make sure my calc's in degree mode. So I've got the square root of 8 times sine 120 squared, add, open bracket, 2 times sine 60 squared, and that's going to give me, what do we want this, to the nearest 0.01, so 7.14. 7.14, could do a better job of writing that, 7.14 centimeters per second. Write the expression in terms of trigonometric functions for the distance the particle would travel along its path, travelling from point A to point B. Do not evaluate the expression. So what we need to know is t here and t here. So this looks like t equals 0. So cos of 0 is 1, so that would put us at the point 4,2, and we can see a is 4,2. This looks like t equals pi, because cos 2 pi is of course 1, so the x-coordinate's back to 4. But cos of pi is -1, and this is at 4, -2. So we want an integral, so the distance is going to be the integral from t equals 0 to t equals pi of the modulus of the velocity function. So that would be the integral from 0 to pi of the square root of 8 sine 2t squared plus 2 sine t all squared dt.